You're in the middle of a sentence. You know exactly what you want to say, and then it's gone. Not vague, not fuzzy, gone, like someone reached into your brain and just took it. You stand there, waiting, searching, and eventually you say, ugh, I'll remember it later. Which, let's be honest, you probably won't. We've all been there, and we've all been told the same thing. Your memory just isn't that good. But here's what nobody tells you. Forgetting is not a flaw. In many ways, it's the whole point. By the end of this video, you're going to understand why you forget, and the answer is genuinely strange. Because it's not just one thing, it's not a bug in the system. Your brain is actively, deliberately erasing information right now as you watch this. And here's the question I want you to hold on to until we get there. What would happen if you couldn't forget anything? We'll come back to that, because the answer will change how you think about your own mind. First, let's get one thing straight. Memory is not a filing cabinet. It's not a hard drive. It's not a camera recording everything you see. That's not how any of this works. Memory is a reconstruction. Every single time you remember something, your brain is rebuilding it from scratch, using fragments, context, and a surprising amount of guesswork. Source 16, Loftus 2005. Think of it less like a video file and more like a Wikipedia article. It exists, it has information, but anyone can edit it, including you. Now, memories form through a process called long-term potentiation. Neurons that activate together build stronger connections over time. The more those pathways get used, the more durable the memory becomes. Source 1, Bliss and Lomo, 1973. And the structure at the center of all of this? The hippocampus, a small seahorse-shaped region buried deep in your brain. We know exactly how important it is because of what happened when a man named Henry Molaison had his removed. In 1953, Henry, known for decades only as HM, underwent surgery to treat severe epilepsy. His surgeon removed most of his hippocampus on both sides. The epilepsy improved. But Henry woke up unable to form a single new long-term memory. Source 2, Scoville and Milner, 1957. Every person he met was a stranger. Every day began the same way. He could remember his childhood. But the world? After 1953, gone. Every morning forever. He lived like this for 55 years. Henry's case gave us the clearest proof we have of how central the hippocampus is to memory formation. But here's the thing nobody told him. His forgetting wasn't random, and neither is yours. In 1885, a German psychologist named Hermann Ebbinghaus did something a little unusual. He used himself as the test subject. He memorized hundreds of lists of meaningless syllables, things like Dax, Bup, Zoll, and then tracked how quickly he forgot them over hours, days, and weeks. Source 4, Ebbinghaus, 1885. What he found is now called the forgetting curve, and it's brutal. Within 1 hour of learning something new, if you do nothing with it, you forget roughly 56% of it. Within 24 hours, that number climbs to 66%. By day 6, about 75% is gone. Now, the obvious interpretation is our brains are terrible at keeping information. But that's not quite right, because Ebbinghaus also found something else, something that doesn't get talked about nearly as much. If you review something, even briefly, just before you're about to forget it, the curve resets, and each time you review it, the forgetting slows down. This is called spaced repetition, and it's why you still remember how to ride a bike, but you can't name 3 things from your meeting last Tuesday. Your brain isn't failing you, it's prioritizing. So the real question is, what decides what gets kept? Most people, including a lot of science communicators, stop here. They say, you forget because memories decay over time. Simple. But that's actually a pretty weak explanation, because if memories just faded from disuse, How do you explain suddenly remembering the lyrics to a song you haven't heard in 20 years the moment the first three notes play? The memory didn't decay, it was hiding. And that changes everything about how we should think about forgetting. There are actually several distinct reasons we forget, and they work very differently. The first is what researchers call retrieval failure. The memory exists, it's physically encoded in your brain. But without the right cue, the right trigger, you can't access it. Psychologist Endel Tulving called this encoding specificity. Your memory is most easily retrieved when the conditions at recall match the conditions when you first learned it. Source 8, Tulving and Thompson, 1973. There's a remarkable study from 1975 that proves this in the most literal way possible. Researchers had two groups of divers memorize a list of words. One group memorized them on dry land. One group memorized them underwater. Then they tested both groups, some on land, some in the water. The divers who learned underwater remembered significantly more when they were back underwater, and vice versa. Source 18, Godden and Baddeley, 1975. The context was the cue. This explains the tip of the tongue phenomenon, that maddening feeling when a word is right there, just out of reach. The memory exists. You just can't retrieve it in this moment. The second major mechanism is interference. This is where memories actively compete with each other. Learning French can interfere with your Spanish vocabulary. Your phone number at your last job can muddy your memory of your current number. New information disrupts old information. Old information clutters new learning. It's a traffic jam. And the more you know, the more jams you get. Source 7, Wickstead, 2004. But here's the question I want to hold open for a moment. If forgetting is just failure, decay, interference, lost cues, why does your brain seem to work so hard to make it happen? Because it turns out, forgetting isn't just something that happens to your brain. In some cases, your brain is actively making it happen. Before we go deeper, I want you to understand why this matters beyond just trivia. The memories you retain and the ones you lose shape your decisions, your relationships, and how you see yourself. When you remember a fight with someone differently than they do, you're not lying. You're both probably telling your version of a memory that neither of you has stored accurately. When you feel like you're bad at learning, you might actually just be missing the conditions that help retrieval work. And when you carry a painful memory that you can't shake, there may be something your brain is doing or trying to do about that. In 2004, neuroscientist Michael Anderson and his colleagues at the University of Oregon published a study that got a lot of attention. They taught participants pairs of words. Then they showed them one word from a pair and told them, do not think about the other word. And here's what they found. The harder participants tried to suppress the unwanted memory, the less they could recall it later. More importantly, their brain scans showed why. The prefrontal cortex was actively inhibiting the hippocampus during suppression. Source 9, Anderson et al., 2004. Your brain wasn't just ignoring the memory, it was blocking it. This is active forgetting, and it's real. Now, here's where things get deeply strange. Every time you retrieve a memory, every time you remember something, you briefly destabilize it. It becomes vulnerable, editable. Your brain then has to restore it. This process is called reconsolidation. Source 10, Nader et al., 2000. And in that window, after you've retrieved the memory but before it's been restored, the memory can be changed. Studies in both animals and humans have shown that interfering with reconsolidation can weaken memories, sometimes dramatically. Source 11, Hopbach et al., 2007. This means every time you replay something painful in your mind, every time you revisit an argument, an embarrassment, a regret, you're not just watching it, you're slightly editing it. Every time. The memory you have today of something that happened 5 years ago is not the original. It's a copy of a copy of a copy. With edits accumulated along the way, we've been treating forgetting as a malfunction. But I want to flip that completely. What if the goal of your memory system was never to remember everything? What if the goal was always to help you make better decisions? That's exactly the argument made by neuroscientists Blake Richards and Paul Franklin in a 2017 paper in the journal Neuron. They argue that forgetting irrelevant details, the noise, is what allows your brain to generalize, to see patterns, to make predictions. Source 14, Richards and Franklin, 2017. A brain that remembers every single detail of every single experience cannot easily extract the general rule. It gets lost in the specifics. And we actually have evidence of this from real human beings. There is a condition called highly superior autobiographical memory, HSAM. People with HSAM can recall virtually every day of their lives with extraordinary precision. Give them a date from 20 years ago, and they can tell you what day of the week it was, what they were wearing, what they heard on the radio. Source 15, Laporte et al., 2012. You might think that sounds incredible, but the people who have it? Many of them describe it as exhausting, overwhelming, impossible to escape. Every slight, every failure, every embarrassing moment, perfectly preserved, forever. This is what Jorge Luis Borges captured in his 1942 short story Funes the Memorious, a man cursed with perfect recall, who finds the world unbearable because he cannot generalize, cannot abstract, cannot move forward from any experience. Borges wrote it as fiction, but it maps onto a real phenomenon with startling accuracy. Now, remember the question I asked at the beginning? What would happen if you couldn't forget anything? Here's your answer. You would be trapped in every single moment, simultaneously. Your brain forgets because the alternative is worse, not because it's broken, because it's doing exactly what it was built to do. Here's what I want you to take from all of this. Memory was never meant to be a perfect record of your past. It was meant to be a tool for navigating your future. The forgetting curve exists because your brain decided most information isn't worth the energy to keep, and it's usually right. The retrieval failures, the interference, the active suppression, these aren't bugs. They are the system doing its job. And here's the part that I find genuinely beautiful. Every memory you still carry, every face, every feeling, every moment that survived your brain's constant editing process, is there because some part of you, consciously or not, decided it mattered. Your memory is not a hard drive. It's a portrait of what you value. The question isn't why you forget so much. The question is, why do you still remember that? If this changed how you think about your own mind, drop a comment. Seriously, I want to know, is there a memory you've held on to that you now suspect has been heavily edited? And if you want to go deeper, the next video covers something closely related: why eyewitness testimony is far less reliable than courts have historically assumed. Same reconstructive memory, real-world consequences. Links right up here. And if you're new, subscribe. This channel is for people who actually want to understand how things work. I'll see you in the next one.